Chapter 11, section 11.1. When you have a positive or negative number, like we have here, x to power of 2 is equal to 9. I want to see what number I need to replace for x that when I raise it to power of 2 is 9. One is 3. Because 3 to power of 2 is 9. But that's not the only number. The negative 3 also is one of the answer. Because negative 3, you have to put a parenthesis around it, to power of 2 also is 9. So in a situation that x to power of 2 is 9, you have two answers. Let's say x2 is 25. X can be 5 or negative 5, because in either case, the answer is 25. So when you have an equation like x2 is equal to 16, what you could do in order to find that 4, or here to find that 5, or here 3, you could take square root of both sides. Means here, if I want to find x, I put a square root on each side, but on the right side, you need to put the plus or minus. Radical x2, since the root of radical is 2, by raising a radical to power of 2, x is released. And here on the right, you have positive negative 3. x2 is 25. So x is positive or negative of radical 25, which is 5. And your calculator has that square root. Like here, it has a different calculator, but this particular one, the square root is right here. See? That's for the square root is. So if I want to find the square root of, let's say 16, it give me 4. Okay, so x is plus or minus 4. Now on this problems, x2 is 225. So x is radical 225. So here, x is plus or minus radical 225, which is, when you use your calculator, is 15. Next problem is t2 minus 20 equal to 0. Now, in order to take a square root, you should have the variable alone on one side. So I don't need minus 20 on this side. I have to move minus 20 to the other side, which is positive 20. Then you take a square root of both sides, so it will be plus or minus radical 20. And then radical 20, if you want to take some numbers out of the radical, that's how to do it. 20 is 2 times 10, 10 is 2 times 5. So 20 is 2 to power of 2 times 5, 2 is released. And that's how you have the answers. So again, to solve it, you must have x2 by itself. Like here is 2x2 equal to 22. First, I need to get rid of these 2 by dividing both sides by 2. So x2 is 11. Then you take a square root of both sides. So this is the first 3 problems. And in either case, remember, the variable has to be alone on one side. I need to take -2 to the other side first. Divide both sides by 2. See? Now I can take a square root of both sides, but remember, you always have a plus or minus because that means you have 2 answers. So it's radical 2/7. Now, when you are using MyMathLab, sometimes they want to write the answer in a different form. So I'll show you here. Radical 2/7, you could just write it as radical 2 over radical 7. Then we rationalize the denominator. Rational denominator means I just want to come up with the answer that doesn't have denominator under the radical. So in that case, I multiply by new fraction, which is basically 1. Radical 7 over radical 7, which is 1. When you multiply these two, is radical 14. What is radical 7 times radical 7? Is radical 49 or 7. So anytime you take a radical and multiply by itself, radical is removed. Okay, like so radical 7 times radical 7 is 7 to power of 2 or just 7. So anytime you want to remove the radical, you just multiply by itself. Now in this one, again, we have to take 49 to the other side. Divide both sides. Now, when you take the square root of both sides, you have negative under the radical. Remember, if the power of radical is even, you cannot have the negative number. Okay? Like, for instance, let's say I want to take the square root of negative 25, right? So in the calculator, you just put, in the calculator, you put square root of minus 25. See, calculator will give you the error. Why? Because when the root is even, you cannot have negative number. So in that case, what we do is we think of complex number. Remember, I is radical negative 1. Anytime you see a radical negative 1, you could replace it with I, the complex number. So here, I have minus 49 over 66. I break it into two parentheses. I mean, two radical, 49, 60, and this one is I. And the other one, you could just remove. So you have two answers. So that's why in the problem said use I as needed. Means if you come up with a negative number under the radical, you don't have the real answer, but you do have a complex number. So this takes care of the first 5 problems here on this sections. All right, now we want to solve this one. As long as you have expression to power of 2, but let's say here, if I have a2 to power of 9, you just write a is plus or minus radical 9, right? The same thing. The whole thing is to power of 2. So what you could do, you could just write this plus or minus radical 9, which is plus or minus radical 3. So now there are two equations. One is x minus 8 is 3. Second, x minus 8 equal to negative 3. So when you solve both, you come up with two answers. See, both of these answers, if you want to check, it works. I put a 5 here. 5 minus 8 is negative 3. Negative 3 to power of 2 is 9. I put 11. 11 minus 8 is 3. 3 to power of 2 is 9. Next problem is very similar to this. So you could remove the 2. And then when you add 6, these are the answers. 6 plus radical 12, 6 plus minus radical 12. Then 12 is 4 times 3. 2 is removed. And that's why you come up with the answers. It's very similar to that one. This is another one. more complicated because you have a fractions on this side, but it would be plus or minus radical that. Then I subtract 7/2 or take it to the other side. See, you have positive and negative answers on this. Because you have a plus or minus, you use the plus one time with minus 7/2, or then you're using the negative. See, negative, and you come up with two answers. Now this problem is kind of different. They're saying that, hey, f of x is that. Find the x such that f of x equal 4. All they're telling you is just f of x is 4, right? Take this 4 and put it for f of x. So you have 4 equal to that, or x minus a to power of 2 equal 4. Why? Because f of x is given, is 4. And then the rest is very similar to the other ones. So you could look at the lecture notes and follow the solutions. The next subject is completing the square, they call it. You know, we have a formula in algebra that if you have a plus b to power of 2 is a to power of 2 plus twice of a times b plus b2. Or if you have a minus b to power of 2, means if you have sum of two variables and difference of two variables. So it would be a2 minus 2ab plus b2. Now, if you write just, if we give you just these two, and we ask you to create that, that's how we want to practice. We give you just these two, and you have to add this to it in order to come up with that equations. Examples. Here, completing the square for these problems. X2 plus 2x. They ask you to find the third term. So you could find the second term here. What you need to do is you need to take half of this number, which is 6, and put it here. See? So that means if you take x plus 6 and raise it to power of 2, you're going to get this. So you see what number is sitting next to x, take half of that and put it here and put it there. What is half of 14? 7. You put a 7 here as 7 there. Now, if it's the negative, then you have a negative here. So you need to understand that. Okay? That's why you have a negative in the parentheses, because x has a negative number here. Let me go to the next one. All right. So now you need to find half of this fractions, half of this. Okay. What is half of this? I'll show you here. Half of 3/4 means 3/8. Okay, so you put that one here and raise it to power of 2, and here, look what happened. You put it here to power of 2 inside. And then what is 3/8 quantity square? 3/8 quantity square means 3/8 times 3/8. which is 9 times 64. Okay. I would disregard this 7 and just look at this. X, what is half of X? Half of 6, 3. So you put 3/2 and minus 3/2. Okay. Why? Because when you're adding something, you have to subtract the same thing too. It's like nothing changed. Look, positive 9, negative 9. Does anybody change? No. But then you take these 3 and you write it as X plus 3/2 minus 9 equals 7. Then you move 9 minus 9 to the other side, which is 16. And then you solve it. Okay. This is how to use method of completing square to solve the problems. So in that case, again, half of 6 is 3. You add 3/2 and subtract 3/2. This 3 is that, and then solve. The last one, same thing. First, take the 3 to the other side. Half of 4 is 2, is 2 to power of 2 minus 2 to power of 2. And then this 3 is that. And why do you have a negative? Because there is a negative. And then you move 4 minus 4 to the other side, and then you solve these equations. This is how to use method of completing square to solve the equations.